Thanks, Jens and Magnus. It's really a distinct pleasure to be here and also have the distinct responsibility of warming up the audience for the rest of the summit. First, 2 corrections. Jan, you should know I am not I. I am Chih-Lin I. The letter I think for Europeans, mostly you pronounce it E, right? Okay, you succeeded. 90% would say I in America, that's true. Second correction is, you notice there is a spelling difference of a keyword in my talk. I'm not here to give you a peak of 5G because I'm sure there are plenty peaks to be found for 5G, okay? I'm here to take a peek of 5G and try to figure out the paths to get there, okay? So it's P-E-E-K, not P-E-A-K. Second correction. Well, exactly 10 years ago, right? We were at the point where ITUR had published M1645, the famous Venn diagram, the Venn diagram. And at the time was targeting 2010. Okay, great. We had 2 numbers to work with, 1 gigabits per second and 100 megabits per second. We all remember that. Well, today, 4G is pretty much maturing. LTE, I think 350 to 400 operators have committed in over 100 countries. And even the younger brother of the 2, the TD version, is doing quite well. Not only globally in pretty much all 5 continents, there are presence of commercial commitment. But also, as you all know, in China Mobile's plan is by the end of this year, we will have deployed 200,000 base stations for the TD-LTE, covering pretty much full coverage of the top 100 cities. And our chairman had also announced that there will be at least 1 million TD-LTE terminals this year, okay, in our system. So, well, there was animation on this page, but somehow this morning when we're loading the file, PPT doesn't work, so this is PDF. No animation, but the content's the same. I think up until the middle of last year, the world were not speaking of the words of 5G yet. Somehow, even though in China Mobile we have started looking at 5G key technology R&D work about 18 months ago. But for the sensitivity of a 4G industry sake, we did not also speak out very loudly about 5G externally. But pretty much 6 months ago, or a little over 6 months ago, I think it was Q4 2012, all of a sudden, the whole world started speaking about 2020 and subtitle 5G. Both the European Union, I think, started with the 5G Now and the Metis, the 2 projects that many aiming at 5G. And then there was this announcement of the reorganized Horizon program. I think, was it 50 million committed already for the first batch of project? And also WWF published their Vision 2020, where I think the keyword is there, 7 trillion wireless devices serving 7 billion people. That's pretty grand. Of course, this summit will probably also cover some of that aspect. And also 3GPP, as of June last year, the Release 12 workshop, we're not talking about 5G yet. It was an evolution of the LTE advance, of course. But now they also have kind of a roadmap towards 2020, Release 13, Release 14. From 3GPP's point of view, maybe the evolutionary version of 5G, evolutionary from the 4G standards. But of course, at this point, ITU has not given us new number yet. So we can have our imagination run wild. We still have enough flexibility and can think big and aim high. So there could be, I think, a good opportunity for yet another revolutionary solution for 5G. And this summit, hopefully, is laying some of the groundwork. And I guess credit to Rahim here. The words first, 5G in the name, okay? Innovation Center is established in UK, funded by both the government and industry. And also, just after Chinese New Year this year, in the middle of February, the Chinese government had also launched IMT 2020 working group, aiming at 5G as well. Okay, right now, as I said, there's no fixed target yet. 5G is something that you can define your own target, whether it's the capacity 1,000 times, whether it's the peak data rate 10 times or 100 times. There may be other criteria and other target that we could look at. Some of it, I hope, later in my talk, I will share with you some of our thoughts. But how to get there, people looking at wider spectrum, higher spectral efficiency, or higher density of your deployment. And in Docomo's case, they also talk about offloading as also a factor of capacity increase. Okay, but of course, it's a bit complicated when we offload traffic to Wi-Fi. We can probably leave that to discussion. Well, so many candidate technology, what are going to be the chosen one or ones? Not clear, because it's like the blind man with the elephant right now, too early. But it can't stop us from exploring the piece by piece. Okay, so I think that's where we are right now, feeling the elephant with our eyes closed. Not that, well, actually in the dark. We are not blind, but right now we are kind of in the dark. Okay, for China Mobile, we have been doing this elephant feeling for the past year. And I think we have learned a few things, and I want to share with you in today's talk, okay? There are a couple key themes, and also a handful of key directions that the remaining of this talk. First of the two is green. Many of you probably have seen some of these pictures. The crying, melting iceberg, the sea level rising, and many of the beautiful major cities in the world in not so beautiful situation. We always thought that our industry, ICT industry, is not really the major contributor. Yeah, maybe not 2% or going to 4%, but you know, even 2%, at 2%, our carbon footprint is comparable to the aviation industry. Can you imagine that? I mean, aviation, global aviation industry, we are actually comparable to that industry. And using China Mobile as an example, I'm showing here the base station growth in the past 5-6 years, and along with the power consumption. Long story short, by the end of last year, we have total a little over 1 million base stations, 1.11 to be exact, where I think 300,000 are 3G base stations. The remaining are mostly 2G, because we are only starting deploying the 4G right now. But with that, we consumed last year 14.3 billion kilowatt power. And as we look to deploy our 4G, as we look to the anticipated traffic growth, we really need to do something about our energy efficiency in the network. we're doing many things which I don't think I'm sharing with you here, but if you're interested, we can discuss that offline. But globally, there have been work done that you are probably familiar with, including mobile VCE's Green Radio, and also ETSI's Earth project. Both had, with great effort, looking at the hardware, the architecture, the operation mode, everything they can do, they managed to get energy gain. I think one was based on HSPA. They achieved maybe 75 to 92% gain. The other is based on LTE. The target was to have 50%, cut it by half, but really got a little bit more than that, but paid a little bit of price of the throughput degradation, 5%. Okay. Green Touch. How many people in this audience know about Green Touch? Not bad. More than, I think, I would say 40%. Green Touch, I kind of view it as a little bit of a virtual form of the old-day Bell Lab, but it kind of rallied globally the research community to work together towards this goal of 1,000 times energy efficiency improvement. So it's a much ambitious goal, 1,000 times. But of course, there is also a question of how you compute it. The power consumption model in the system actually is something that our industry from the beginning did not really pay great attention to. Okay, last week in Shanghai, Green Touch's face-to-face meeting, there was an announcement made that based on the past 3 years' effort by the member, the prediction is that by 2020, actually, the total power consumption would be reduced by 90%, even taking into consideration of the traffic growth. I think if this, I shouldn't say if this is true, I think this being claimed, it's very encouraging, and we really need to get into more details to understand the technology that's involved and how to make it into real existence. But it sounds very encouraging. Okay. So green is the first one, and the second one is soft. The two themes that we feel that are very important for 5G. Soft, why soft? For cost, for efficiency, for agility. We all know in our industry, every time you have a new standards, a new release, new whatever coming, most of the time it's not a software upgrade issue. It's you need new boxes, you need new integration, you need so many things new, and takes a long time. And we also know that while our industry, ICT industry, is the combination of CT and IT, right now IT has upper hand. Because the IT industry taking the form as OTT joining our service, they have a much shorter time constant in producing new product and new services on our platform because it's pure software. And they are reaping much bigger the benefit, have much higher return of investment. And we need to change that from our own side. We need to become much more flexible, reconfigurable, and soft. Actually, soft is not new in our industry. Remember SDR, software-defined radio? It's been over 20 years, I would say, right? And SDN now in the core network, it's becoming a reality. But for us, what we like to see is end-to-end. It's a pity we lost the animation. How many of you know about NFV? Hands? Oh, not too many. Not too many. Why? Are we mostly the RAN side of the experts? Okay. NFV has a goal of wanting to transform our infrastructure into from kind of fragmented special purpose hardware into platform building upon common IT servers, switches, and the storage. Make it soft. But true, from what we saw, the end of last year when FV was being planned and the white paper was being drafted, it was mostly the core network. They only get to, I think, SGSN, GGSN. And I think we caught it in time. We added one piece, which is here. We added RAN into it because we feel that only if we can really get to end-to-end soft reconfigurable state, we can truly reap the benefit of what the IT industry is providing. So actually, many of you have heard of CRAN, I hope. Anybody who hasn't heard of CRAN? No. Good, so this page is for you. Okay. CRAN, people often say, what is C? And we say C is not just one C. C is centralized, it's collaborative, it's cloud, and also clean because it's green. But long story short, basically, you pull all the baseband unit that has been sitting alone in the traditional distributed base station housing. You pull it out and put all of them into a centralized site, and you build a baseband unit pool. Okay. Once you succeed in doing that, there is you open up a lot of possibilities and opportunity. First of all, in terms of energy saving, we have seen in our field, in our network, in new deployment cases, we can save 71% of the base station power consumption when we go this route. Because in the base station site, you will only be left with the outdoor RRU unit together with your antenna. And the digital processing, the baseband unit, are put back to the central spot. Okay? And in terms of deployment time, it's much faster. And in terms of the CapEx and OpEx, I think we save 15% and 50% respectively in our field. That's our experience. And more importantly, 4G is the first standard that has this COMP feature, right? Collaborative multi-point processing. Currently, the standards is assuming that it has to go over the X2 interface, the transversal traffic among all of the base stations, which we believe is not really scalable. Okay. Whereas the CRAN architecture, once you put all of the baseband unit to the central spot, the collaborative processing, it's much, much easier and can be done a lot more elegantly. And cloud, of course, naturally, once you got the baseband processing into the same spot, then we say, why do we continue use the special purpose hardware? Why don't we now try to really start building soft base stations, soft RAN, using common IT platform with virtual machines so that you can even have multiple standards coexisting on the same platform. On top of that, virtual machine, you can also provide service on edge type of capability on the same platform. So, of course, there are technical challenges because the real-time requirement in the RAN processing is 1 or 2 order of magnitude more stringent than the traditional virtual machines, high-layer applications real-time requirement. And there's different way of solving that, and we are working on this. And also in terms of the scale or the pool, currently, I still don't have a final number that really convinces me the scale of the cluster should be, I don't know, 19 or 57 or smaller 3, like the standard body is talking about, or 9, for us to reap the full benefit of comp. But of course, the more the merrier. The ability to pick 2 or 3 signals among the larger cluster, the larger the better. But we also did another analysis for the scale, which is economic analysis that take into consideration of CapEx, OpEx for both the base station equipment as well as the transmission, because the front haul becomes the challenge. Because what we need to pull back to the central spot is no longer the baseband signal, it's a digital RF signal. Okay. So with that economic analysis using the data in our own network, currently we found there's a sweet spot which is about 100. Okay. Okay. Now, with green and soft in mind, let me share with you the 5 pearls, and let me explain to you why I call it pearls. Because the elephant is really not that pretty, right? So let's, instead of calling the future 5G an elephant that we don't know how it looks like, I think a much better image would be it's a pearl necklace. Okay? How long is it? How big are the pearls? And what's the color, shade, and size on this beautiful pearl? We don't know yet. What is our job right now, including at this summit, is first find the pearls, polish it, make it ready, and then we'll have enough collection of it. Finally, maybe not all the pearls get on the pearl necklace, but we got pick and choose from the collection. Now let me show you our collection. We have 5 pearls currently. The first pearl, I call it EE and SE co-design. Okay? From 1G to 4G, there was one ultimate target and criteria for our standards design. SE, spectral efficiency, bit per second per hertz. I think looking out for 5G, we have to put side by side with SE another one, EE, bit per second per watts. Okay, it has to be a joint design. Okay. Because green is important. Not only that, but also because if you don't do that, then you would feel like many of the expert and leaders in our field had been saying or crying out, saying, there's nothing left to be done. You know, it reminds me of 20 years ago, in the early 90s, I think our colleague cried the same thing. There's nothing else to be done because the Shannon limit is there. We are touching it already. So what's left to be done? Then, thanks to our colleague, Renato back there, as well as another dear friend, Jerry Fraschini, they came out with the generalized Shannon. So the Shannon equation transformed forever from a scalar equation to a vector equation. So MIMO bought us another 20 years. The last 20 years, I think the theory of MIMO, the unified approach, has given us a lot of guidance of designing new systems. But now, okay, now beyond MIMO, what are we going to do? Okay, I'll tell you what we do. We do EE and SE co-design, because when you look at the Shannon that way, you rewrite Shannon equation into actually 2 parameters, exactly the E and SE. The equation looks, if you plot the equation directly, it looks like there is a monotonic trade-off. Okay, first question is where are we on this curve, right? But that's not all, actually, because Shannon equation only looked at the power transmitted over the air. But that's not all the power that's required for our system. In the base station, there are circuit power, signal processing power, computation power in the back. And that should be considered, especially for the future when the cell size becoming smaller and smaller, because the transmission power will no longer be the dominant component. Okay, and when you look at the total power in the base station, then actually the picture changes. Instead of being a monotonic trade-off between the EE and SE, it's actually depending on the relative dominance of the computation power versus the transmitted power. Actually, it becomes a curve like this. So there is a region where both EE and SE are increasing. There's a peak, then it comes down. It's very interesting. My team member tried to do analysis, which I'm not sure it's final. But since this summit, by its nature, I think I can share with you that what they found is that actually both from GSM to LTE, we are on the rising part. We are not at the peak yet. Okay. And the other thing is that if you look at, if I stay with the same EE, actually, there are two SE solutions. I think these are all very interesting findings, and but we are far from having a unified EE-SE theory framework. Just give you an example, Earth project that I kind of briefly highlighted earlier had one energy saving mechanism, antenna muting, meaning the fewer the better. The fewer antenna being on, the higher the energy efficiency would be. However, there is the other system, LSAS, which is kind of a extreme case of massive MIMO people are talking about. In LSAS, it says very clearly, the more the merrier. The more antenna you turn on, the higher the spectral efficiency you get. Isn't this very strange? I think it's all the reason why we got this totally opposite conclusion is because we are not on the same same level in terms of the assumption. For example, not that I have the final answer because I'm actually looking forward to partnering with everybody to come up with this unified EE-SE framework. Okay, here, this is work by Tom Mazzata, Renado's colleague, Bell LSAS. It shows that if you only consider the over-the-air power, yes, it's a monotonic trade-off in terms of EE and SE, and also the more the merrier. Then if you consider not only the over-the-air power, if you also consider the computation power, that which grows with the number of antenna you turn on, then you would have a very different shape of curves. Okay, and then there is this another work by a member on my team, Chih-Lin I. He considered actually the LTE system, looking at not only the computation power grow with the number of the antenna, but also, in some sense, also changes with the number of subcarriers that's active, depending on the traffic load. And it turned out here, antenna muting seemed to make sense because while you still have subcarrier to turn on, you just stay on subcarriers, and then once you reach the peak, you will see that it drops to the next stage that you should turn on the second one. So I think this one is consistent with the antenna muting. But still, I don't think this is the final answer because the assumption that Chih-Lin made, as well as the assumption that Tom Mazzata made, neither of it is complete. It's just, I think, a starting point. But more, I want to use this example to show that there is a open field yet when we relook at Shannon, but we look at both SE and EE simultaneously. Lots of work to be done. I think professors should be very happy with that. We are very happy with that too. Okay, the second pearl is no more cells, in quotes. What we mean is that no more traditional cells in your think of 5G. Because even up to 4G, I think all the previous standards, when it was conceived, it had underlined the same model that Mr. D.H. Ring had proposed in 1947, the original cellular concept. All the cells are the same. The standard air interface was designed to make with that assumption. But later on, we were making all kinds of changes because we all learned enough now that the traffic is not homogeneous, neither in time nor in space. So there's various effort, okay? COMP is one. Breaking the signal processing is not just centralizing one cell, okay? And the DAS, of course, the radio resource management, and HEADNet in terms of coverage, and the BCG. This is actually a terminology that Green Touch uses. I think they were the first one who started talking about having big umbrella cells for majority of the signaling and control, and the small, high bandwidth, small coverage cells for data, kind of with HEADNet and CU separation. Break the protocol also from the traditional cellular mindset. And I believe CRAN would be a underlying fundamental element in whatever the future 5G would become, because with this architecture, it enables the flexibility that we would need. And also, it could be done even to this degree. You would have not only the unicast, but the multicast and the broadcast, different coverage, and the control and data separation. With a CRAN underlying architecture, this kind of amorphous cell concept would be easily realized, or much more easily realized. So normal cells, okay. 5G, from the beginning, we should have that in mind. Not the traditional one-tier cellular architecture. And the third pearl is to rethink signaling and control. Here is why. Even though our network has become full IP, packetized, and I'm sure there are connection-oriented as well as connectionless sessions in the network. However, over the air, we are completely connection-oriented, even in the 4G protocol. And then what's the consequence of that? Here my team did also kind of preliminary analysis, analyzing VoIP over LTE versus service like IMQQ, instant messaging over LTE. I think we also did WeChat, which is more like a multimedia form of the IMQQ over our LTE internet. We used the real traffic profile, and then this is what we found. Depending on the mobility, in the VoIP case in our LTE, the use for data versus the signaling overhead, we call it data signaling ratio, okay? In the VoIP case, it's between 100 and 600. That means we spend maybe 1% or less overhead to provide the VoIP in our 4G network. But in the instant messaging case, that ratio is less than 1. And as the mobility increases, as the user moves, it quickly drops to like 0.2 or 0.3. What does that mean? It means basically all the time we are spending more radio resource for signaling and control in this type of services. Sometimes even three times or 4 times wasted as overhead, not as used for traffic. And this is the consequences of, no problem. This is the consequences of, I believe, the underlying mindset of connection-oriented radio interface or air interface that we have. And in anticipating the growing importance of mobile internet and anticipating unpredicted, unexpected new type of traffic profile that will ride on our network, even probably before 2020, but certainly after 2020. I believe we need to not keep on building upon our 1G, 2G, 3G, 4G signaling protocol. I looked at one of the analysis my team did. It's such a jungle if you look at the current protocol stack. I think we need to get out of there and rethink 5G. Okay, I got a sign from Yan. So I need to hurry a little bit. The fourth pearl that we at China Mobile feels very close to heart is that we really want to make base station invisible. Make it invisible, not building those ugly fake trees, okay? You remember those fake trees in the 90s? Pretending to be a tree, the base station, really ugly. We want to disappear, especially in the cities. And how? On this chart, you see that we highlighted the walls of the building, okay? We want to use the walls of the building as the substrate of the base station. And we are working on large-scale antenna arrays that each element, actually the active antenna with the radio unit, okay, would look like a small tile, very thin, small square or rectangular shape. And that would be the fundamental module for us to build and to lay out in arbitrary patterns. Here I'm showing a character, 中, which is the first character of China, 中国, okay? This is, as you can see, is not a regular grid as we typically when we think of antenna array. However, the scale, we are thinking of a regularly placed element, A by A, whatever. But we are looking at irregular pattern. And we think there are also some fundamental, interesting questions professors can help us with, which is it a half a lambda? Is it one lambda? Or is it half a lambda in one dimension and one lambda in the other dimension? What is the requirement when we do the irregular placement? Okay, and really would look forward to partnership on this. And of course, to accomplish this, first, the antenna and the radio chain that follows each element would be important because we will want to miniaturize it and low power, low cost. So currently we are building a prototype where we want to use terminal grade RFIC and the components for each of the element, not base station grade, so that it truly will be low power and low cost and take advantage of the scale of the terminal market size. The other thing, of course, is the algorithm. Is it a massive MIMO? Is it LSAS? We are right now analyzing one aspect is that we're looking for the sweet spot of n times m. Let me explain what n times m means. If you look at our current base station, when we say 8 antennas, we are actually talking about 64 elements. Because in each antenna, we actually have 8 polarized elements lined up to give you the beam. But if we have now a couple hundred or even 1,000 elements that's forming one unified antenna array, however we place them, what's the best breakdown factor to give us enough degree of freedom, yet good performance, and reasonable complexity in the algorithm? Okay, that's something that anyone who is interested to collaborate with us would look forward to. Finally, the fifth pearl that we have right now is not that we want to be different for the sake of being different, but so many people are talking about 5G needs 10 times or even more spectrum, so let's look up high spectrum. Some went to 28 gig, some went to 60 gig. That is all fine. we believe there will be roles for very high band. But what happened to coverage and mobility? 5G cannot be just scattered spot of very high wide bandwidth pipe and no coverage and mobility consideration. But that's not really a big problem, because by 2020, I think even China should be ready to reuse the 2G spectrum. But what I'm a bit worried is right now, different parts of the world, some are moving faster in refarming 5G. And they may use it for augmenting the 3G or maybe 4G, I'm not sure. But I would like to propose reserve 5G for the 5G day, and whether it would be a special purpose complementary piece of the 5G together with the high frequency band component, or it actually could be signaling umbrella for mobility continuation or something. But that's something that we are looking at, and I'd like to know your view. So, good timing. My summary: 2 keywords, green and soft, okay, and 5 pearls so far. Thank you.
Okay, we have time for maybe one question. Go.
Yeah, Mikko Ostolo from Nokia Research. Thank you for an excellent talk on this topic. And about the elephant that you are kind of trying to touch in the dark, if I would need to put it in one word, I would say efficiency. And that covers many of the things you are looking at. And especially you are interested in this energy efficiency, and you said that there is visible. It is visible that we can reduce by 90% of the energy consumption and still cope with the increased traffic. And then you were telling several factors contributing to that. And is your interpretation that with those factors that you presented, we can get this 90%? That's first part of the question, and second part is that are you happy with that? So how far further do we need to go? So have you already solved our problem with this energy efficiency?
Thank you, Mikko, right? Thank you for the question. I totally agree with your one-word summary, efficiency, because green is for energy efficiency, soft is for resource efficiency. Okay, yes, so efficiency. And then your second question, I don't think, first that question about the 90% energy reduction, taking into consideration of traffic growth, that was an announcement Green Touch made. It's not me or my company, okay? And I said that I'm very intrigued with that result, and our team, we are looking into more details to see how that computation was arrived at, which I'm sure because it's led by many notable leaders in our industry, we should have confidence in it. But how exactly it was done, we are still kind of investigating it. And whether I'm happy with 90% reduction, this is my personal opinion. I think if our traffic grows 1,000 times and our total energy becomes 10% of today's, I would be very happy, okay? I would be very happy. But I think chances are the way that the number was arrived at by the members of Green Touch was with some assumptions and also some technologies that are yet to be realized, and there must be challenges in realizing it, okay? Actually, I was a bit surprised. I originally, when we joined Green Touch, we thought that if we can improve the radio side, the energy efficiency by 1,000 times, I would already be, celebrating with firecrackers. But now it says it's not only you can deal with 1,000 times more of traffic, but also the total energy consumption not only did not increase, but also become 10% of the original one. I think you should be happy too, if we can get there.
Okay. Misha.
Yeah, Misha. So I have one question, one comment. So the question is on, you haven't mentioned self-organizing networking even once. So it seems like, in the Western Hemisphere, people try to talk about, distributing tasks, self-organizing, so on stuff, yeah. Whereas in the Eastern Hemisphere, you try to centralize everything, and particularly the C-RAN seemed to be a very centralized kind of architecture to me. So any thoughts on that?
Okay. If we think of song, yes, maybe one interpretation is self-organizing totally in a distributed manner, right? But if you look at the network-wide, as an operator, we would like to think the network is self-organized with centralized mechanism as well. Not centralized. I mean, if we do it at the level of the C-RAN, the baseband pool spot, okay, you can, from the operator's point, self-organizing your network dynamically, according to the traffic, according to other conditions. So I think it's a matter of how you define song. And also, I'm not saying that in our network, individual nodes on individual cell site will not have some capability of dealing with maybe the local interference or local traffic need. I'm not rejecting that at all. Okay, and I'm also, like I said, the 5 pearls is just the beginning. I'm not saying that there's only 5. Actually, I'm looking for a lot more. These are the 5 that we're starting with.
I think you have a chance to come back in the breaks to discuss this very important and interesting subject. So thanks again, Chih-Lin.
Thank you.